Histogram is a useful way to illustrate the frequency distribution of continuous data. You know that continuous data means it is not plotted against a particular value, but it is plotted against a continuous range of values. Here, if you can see, it is 2.5 to 2.9, 3 to 3.4, 3.5 to 3.9. So, instead of a single data or single value of x, it will be a continuous data value in histograms. Histograms even can be of two types, one with uniform class width and the other with non-uniform class width. See, for example, this case. Here we have the class width as 2.5 to 2.9. See, 2.5, the values can be either 2.5, 2.6, 2.7, 2.8 and 2.9. What does this mean? There are two people with lung volume, either 2.5 or 2.6 or 2.7 or 2.8 or 2.9. Similarly, 3 to 3.4, that means there are 5 values, 3.0, 3.1, 3.2, 3.3 and 3.4. For these 5 values, the frequency is 5. In this case, it is very easy to plot a histogram like this. We can just plot the data values, that is the class widths and the frequency against this. But if you check into this example, here also the lung volume is given and the frequency is given. But what is the difference of this from the first case? Here the lung volume is 2.0 to 2.9 in the first case, 3.0 to 3.2 in the second case, 3.3 into 3.5 in the third case, and so on. So what is the class width here? The class width for the first case is 1. Why it is 1? 2.0, you count the number of values, 2.0 to 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8 and 2.9. There are 10 values of 0.1 each. So what is the class width? 10 into 0.1, which is equal to 1. In this case, if you check, it is 3.0 to 3.2. So which all can be the data values? It can either be 3.0 or 3.1 or 3.2. That means 3 data values of 0.1 each. That means it is equal to 0.3. Here also it is 3.3 to 3.5. 3.3, 3.4, 3.5. That means 0.3. So this is how you find the class width. If the class widths are different, then you cannot plot directly against the frequency. Instead, you have to find the frequency density. The formula to find the frequency density is frequency divided by width. For that, you already have the frequency. You have to find the class width. See, in this example, 2.0 to 2.9, as we already discussed, the class width is 1. Here, if you can check, 4.1 to 5, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9 and 5. There are 10 data values of 0.1 each, so that the class width is 10 into 0.1, which is equal to 1. Here it is 5.6 and 5.7. 2 data values of 0.1 each, so the class width is 0.2. So whenever the class widths are different, the first thing to plot the histogram is to find the frequency density using the frequency and the class width. See, the frequency density is 2 divided by 1.0, which is 2.0, or 2 itself, 6 divided by 0.3, which is 20, and so on. In the same way, you are requested to find the frequency density, and instead of frequency, we will be plotting frequency density against the data value. See, from 2.0 to 2.9, the frequency density is how much? It is 2. And 3 to 3.3, how much is the frequency density? See, it is 20. Similarly, you can plot the frequency density. So the whole idea is that if the class width of the classes of the frequency given are the same, then you plot frequency directly. If the class widths are not uniform, then find the class width and find the frequency density by dividing the frequency with the class width, which will give you a histogram plotted against the frequency density. Now, how to solve these kind of questions? Here, we have given an incomplete histogram as well as incomplete table. We have to complete this histogram based on the table given, and we have to complete this table based on the histogram given. See, here we have been given from 20 to 25. What is the frequency density? Frequency density is, for example, see, 20 to 25, we have the number of people. Number of people means it's the frequency. We have the frequency as 24. And what is the class width? See, it is from 20 to 25 including 20. So what is the class width? 20, 21, 22, 23 and 24. 25 is not included. So the class width is 5 and frequency is 24. So what will be the frequency density? It will be 24 divided by 5, which is equal to 4.8. That means this point is how much? 4.8. This is 4.8. Sorry for my writing. So this point is 4.8. What does it mean? This whole one big square is how much? It is 1, correct? So here it is 1, here it is 2, here it is 3, here it is 4, and this is 4.8. Okay, now we have to draw this. We have to complete this histogram. Here if you can see, the number of people or the frequency is 38. And what is the class width? 10 to 20 including 10. That means it will be 10. Okay. So number of people is 38. 38 divided by 10 is how much? 3.8. That should be plotted here. So 3.8 will be almost here. So this is how you plot this histogram. Now if you can check, this is 25 to 40, that is 63. 25 to 40 means the class width is 15 and the frequency is 63. So we have to find 63 divided by 15, which is equal to 4.2. So this much is 1, 2, 3, 4 and 4.2. So this is how till 40 we have to plot this. This is 4.2. Now we have to fill in this table. How much is this actually? 10, 20, 30 and 31. Okay, that means 3.1. So what will be frequency if we have been given the frequency density? Since frequency density is equal to frequency divided by width, what will be frequency? That will be frequency density into class width. Frequency density is 3.1 and class width is 40 to 50. That is how much? 10. So 3.1 into 10. So what will be the frequency? It will be 31. Now about this question, 50 to 80. So what is the class width? It is 30 and the number of people is 24. So what we have to find in order to plot frequency density? It is 24 divided by 30, which is equal to 0.8. And where can we plot 0.8? Here. The drawing should be accurate. Sorry for my drawing anyhow. This is how you find the frequency from the histogram and you plot the frequency density from the frequency. The only formula that you have to apply here is frequency density is equal to frequency divided by class width and frequency equal to frequency density into class width.